It's more than a year right now that I started to follow the serverless path. But first thing first, few words about me. Who am I? I'm Paweł. As I introduced myself, I'm cloud architect or pattern match. As a pattern match, we focus on performance improvement, especially using cloud efficiently. Also trainer at nativenachmuła.pl. Check it out. These are practical workshops related with two cloud topics, like containers, serverless stuff, monitoring, and things around it. We are conducting this workshop around Krakow area, in Silesia too. And I have around 10 years experience with large-scale systems. I work mostly on AWS cloud, and this is a technologies I'm familiar with. Here you can find me if you want to follow me or check the Pattern Match website. And I will start to giving some context to this presentation and to what I'm going to speak about. This is the first time I'm saying about this publicly, but I was addicted to servers. I used to deploy hundreds of them every week across 5 different data centers. It was both AWS at some point and on-premise, and it got worse at time and time. In the end, that's how my life looked like. And we used to exchange a lot, this image, to our Slack channels. The big project was in the AdTech industry. We were taking care of one of the largest ad exchanges at that time. Of course, I'm not counting Google and Facebook. They were far away. And yeah, if something can go wrong, it will go wrong. And you will see even on-premise stuff like fan blew up, disk is down. And also on the AWS side, like there was even this S3 outage at some point, which brought down the whole data center. In our case, we were not able to deploy as all the artifacts were on S3. And yeah, there's a lot of crazy stories. And the biggest takeaway is that we had to plan our capacity in front. We had a meetings like 3 months before big events. How much capacity do we need? And how many servers do we need to order? And the company itself decided to move to the cloud, despite the fact they had a lot of their own data centers. And yeah, but it was still burning. So I decided to quit and start doing serverless. Switch the project completely and the client, and join the serverless approach. It was like 1 year ago, and as you can imagine, peace of mind, that kind of stuff, fairy tales, unicorns all around. But seriously, it was a big mind shift at that point, because a lot of stuff I used to worry about, just disappeared. So I will quickly introduce the serverless, what it is, what are the main features of it and main benefits. Then I will show you what we have built during the 1.5 year, and when it was good and when it was not necessarily good, but probably it will improve in the future. So quickly, what is serverless? Of course, as Tomek also mentioned, there are some servers somewhere. It's only the fact that they are hidden. And according to wiki page, it's more about changing how you bill your compute power than like hiding something and getting rid of it. That the way we pay for resources, we don't pay for reserving a capacity, but for the actual usage in the serverless computing model. And it's like, for me, it's natural evolution here. So we started with our own resources. Then there is first abstraction, the infrastructure as a service, that we can reserve or order some parts of infrastructure, despite the fact that it might be on 1 or 2 hosts or many more. Virtualization comes into place. Then we have platform as a service, and in the end, serverless, where we totally forget about operating systems, operating of machines. The only thing that matters is unit of code. It's a function that your platform has to run. And serverless approach as a whole is not only about the lambda, so the second guy here. It's also the storage part, like S3. You have a DynamoDB. Here, if you can recognize, it's recognition. So you have some parts of machine learning as a service. In that sense, CloudWatch and API Gateway. You break things into small components, and you build them as you use them. So that's the first feature I want to focus on. It's that you pay for the actual usage, for the actual time spent. You don't pay anything up front. You might say that in case of free, you pay something for storage, but that's actual usage. You don't pay for the ability to store 100 terabytes, for example. And it's a very convenient approach because the costs scale with usage over the time. The more you use, the more you pay. Especially you have some kind of dev or QA environments that are not used during the weekends, during the night. You don't have to take care about them and reduce down number of hosts, for example. You just have this mechanism for free. And if we're speaking about money here, that's how pricing looks like. For the Lambda, you pay 20 cents for 1 million requests. And the other thing that matters is duration. So we have like two toggles here. One is the event processing, incoming events, and the second one is duration. And duration matters on the size matters in that case, basically. So the bigger Lambda, the more you pay for every second of it. And if you want to compare it to the classic approach, it would be much more cheaper if we have a small shard Lambda. So it is half a gig, 20 times per month. That is like 50 times cheaper than the smallest instance. However, at some point, Lambda becomes more expensive than the classic approach. In this example, we have 2.5 gigs, 30 million requests, and 50 seconds per each request. Event request. I will exchange this, but you know what I mean. And in that case, probably it's more efficient to run the instance or a container somewhere. And yes, so it's not a silver bullet. It's not the cheapest way possible. As we mentioned, it's event-driven, so we have a lot of triggers. It might be HTTP request coming in. It might be S3 object, upload, CloudWatch event. The same story with S3, for example. You pay for putting objects, for getting objects, etc., etc. In case of Lambda, we have also a limit, so we have maximum 15 minutes. That after that time, the Lambda will be killed. If you want to have longer runs of complicated state machines, take a look at step functions. That's probably something you need, or just fall back to containers. That's also the way. And everything is on demand. You have scaling included. Don't need to worry about it. Of course, to the certain level. After you hit a very, very large thing, you might need to even increase limits or hit the limits. And yeah, the byproduct of that is Lambdas or any other service not necessarily ready to use at the moment. Sometimes it takes some time to scale it up behind and to get it full speed. And yeah, let's jump to the project. And what does it do? It just saves money. And there are two options, right? Generate money or saves money. I'm not allowed to give much details about it, but basically this was a system on top of existing systems which were working on goods that are refundable. So you have flights, bookings, maybe concert tickets or any other stuff that you reserve up front. You have a certain deadline till which you can cancel this reservation and get your money back. So there is opportunity because, for example, if you have flight which you can rebook, the price fluctuates over time. It's not a fluctuation like on the stock exchange that it changes every second, but you have a hot deals, last minute kind of stuff. So if you can cancel original reservation and buy cheaper one. Maybe it's not a big gain for me and you, but if you're a big company, you have a lot of travelers there, even 5% of savings within a year is a big difference. It can be a big difference. So our software was running on top of existing systems. It was not integrated in one of them, just collecting and interacting with them. And with one simple goal, to collect all the reservation and check if there is better offer. If so, do a rebooking. Simple as that. And how I started, I joined at the very early phase. I was not present at the designing from the day zero, but they had already a first prototype. It was not live. The team has changed at that time. We're there to help them continue with the project. And there are two main goals. First, to validate on the pilot customer set, and then go live with it. And simplifying it a bit, that's how it looked like. We got the event stream, notifying us about reservation, what are the IDs. Then we had a collection phase when we stored all the information necessary for external APIs and put it into the Dynamo. Then at least once a day, we just were pumping all those reservations to the queues for the offer check. Do we have cheaper offer here? If so, put it down. Do the rebooking. Notify a lot of, this is like a business heavy side, notify a lot of subsystems, do connections. That's because normally a user would be worried why my flight was canceled, for example. What's going on? You need to create a connection somewhere to let them know that something like that happened. And in the end, it just went through again to the even new reservation was coming in, was collected, and so on, so on. As I said, it's simplified a lot. I missed things like logging at every stage. We use Google Cloud for that. BigQuery to. At each step, we're putting information about the offer, the reservation itself, and so on for later business analysis. And what challenges we had at each stage? Here, first of all, there was a lot of collecting and calling external APIs. And why we stored in Dynamo instead of having one big stream? Mostly due to easier debug it. If you have it in a central place, you could just go to the database, check the status, do some kind of retry, modify it. There was also the time at which the GDPR was introduced. So it's also another requirement coming from outside that we need to extract all the personal information data. And Dynamo was perfect for that. Then we had a pumping phase. You probably wonder why we have this Pursman priority queues here. This is SQS, by the way, in the new logos. Because we have different kind of customers. Of course, there are very important customers and less important and even normal people. So in order to make priorities out of it, we created many queues, and during the pumping phase, we're just splitting through the queues. Sorry. And yeah. Then we had the offer check. Why we didn't use sophisticated queue? Because we didn't want to leave serverless land. And this was the very good decision. If we introduce some RabbitMQ or something like this here with priorities, different channels, then we will lose what we have here. Like everything is serverless. We don't have to babysit any servers here and so on. Then the offer check. We used CloudWatch events to trigger lambda with certain parameters. So the high priority queue was triggered like every second, while the other ones were triggered less frequently. And there was another requirement here, these external APIs. If you ask about offers, the many companies have some kind of limits, because this is not a part of their business to display your offer all the time. They want to have certain ratio between offer and booking, because that's what they get money for. And Plus, our part of our system was overloaded at that time, so we need to have a smooth line rather than, hey, we have 1 million reservation and let's check it out through the hour and kill all the services. So the lambda here with the reduced concurrency was another Pursman mechanism for throttling and rate limiting at some sense. It was good enough. We don't need to implement anything sophisticated, like just spawn 5 lambdas and they will just pinging the service for the whole day. Then if we got something, we pushed it to the fulfillment phase. And at fulfillment phase, we did a lot of business things. Here the main challenges were rather business. You have cases like credit card bookings and so on, how to rebook them, to be PCI compliant, etc. So that was a heavy part, but not heavy in technical sense. The hottest thing was here. And what is current status? We're on production. We're scheduling around 1 million ETMs every day, and it was handled by 4 people. And thanks to serverless, we focus mostly on business logic and business difficulties. We don't need to fight with infrastructure, as it used to be before in my career. Like the half of the work was like keeping servers up. And at that time, at this moment, we're experimenting with machine learning, comprehend, for better offer comparison. So we try to parse the offer description to extract extra amenities to compare to. And it's also serverless way, and yeah, we'll see how it goes. And what was good, there is a slogan that there is no ops involved in that process. However, this of course is not true. You still have to make your infrastructure as a code. You still need to configure all the VPCs. You need to take care of permissions, security stuff. It's not like that the problem disappears. It's still there, but it's much less effort to do it. You get rid of system updates, security patches. It's much better. We use Terraform for that. I personally don't recommend it, especially for serverless heavy things. There are better ways to do that. It's not that Terraform is bad in some sense, but it introduces a lot of boilerplate that is not necessarily needed here, especially that we had a multi-repo approach at that point. So every Lambda has a separate repo, separate Terraform scripts. There was no like sharing, and Lambda's supposed to be small, right? And if you have a lot of small functions, a lot of Terraform, sometimes it's hard to tell, for example, which queue belongs to which component, and that kind of problem. Right now, I'm inclined to use monorepo approach when you store the Lambdas, especially with given boundaries, not like all Lambdas, but if you have one logical service, it could store many functions inside to make things easier. But serverless framework or serverless application model is a better way to do that, especially that you get local run for free, which with Terraform is not so easy. We have instant deployment. At the ad-tech times, yeah, the premium soup, it takes longer to make than to deploy Lambda, especially the more steps involved. You need to pour this fatty thing, then spices and so on. And in case of Lambda, you just upload the package, and that's it. And tell the Lambda that to pick a new version, and it will replace over time. It was a big shift for me because during these ad-tech times, some of deployments took half a day in one region. So yeah, we're doing rolling deployment, so that is why. But there is also a lot to do, a lot to check, to validate during that time. And scale, putting load balancers off, putting on, and so on and so on. And yeah, here, like the deployment experience is perfect. You just put it and let the AWS do the heavy lifting for you. There are things like canary deployments in Lambda involved and versioning, but we haven't used that. It was not necessary for us due to batch nature of this whole component. Because if something went wrong, we could always retry. So nothing really bad happened. And we relied on GitLab pipelines for the versioning. So every GitLab tag had a run button to deploy. If you want to roll back, you just run the previous pipeline again. Simple as that. But the Lambda and serverless world is perfect, in my opinion, for prototyping. You need nothing to start, really. You just open this, as Tomek even showed you, and you're ready to go. And really ready to go. At some point, we decided that we need a relational database to store configuration. And we took a look. Maybe Aurora serverless would be a good fit, as it's still in the serverless world, which we don't want to escape. And just open the editor, make a simple queries. That's how much we need from it. And OK, we have it. Let's run it 100 times. Bam. And the whole validation took half a day instead of writing load testing scripts, et cetera, for a couple of days. The main pain was to just set up networking correctly. And yeah, but you can do it also manually, locally, not manually, using serverless framework or serverless application model. I really recommend that approach. The tooling is much better than to do it in Terraform or by hand. You can get up running very, very quickly. And then you have a prototype. You're ready to go. The only thing you want to do right now is to scale it to your production usage. There are two sliders, one slider and one input. You just reserve a memory. One fact that's not obvious from the beginning, you probably know that at some point, probably 1.5 gig, you get extra core here. So you have Lambda with 2 cores. But the memory also influences networking. At our pumping stage, we had to scan the whole DynamoDB and put it in the queue. So from the code perspective, it's very simple. We have a Lambda. It was in Node.js. It was just scanning the DB and putting into the queue. It's like I/O bound operation, nothing that requires compute or memory. But it turns out that if we go for at least half a gig, it was like 5 times improvement in terms of speed because of better networking. The latency is much, much smaller. And yeah, it's logical because if you have a bigger Lambda, it lands, the Lambda containers goes to beefier machine. And beefier machines on AWS have better networking. So keep that also in mind. And concurrency, as I mentioned before, it helps a lot with, if you want to do a simple throttling. You just reserve 10 lambdas, and you're sure that they won't exceed. Of course, if you have a complicated use case, that won't work. But if you more or less want to throttle something, it's perfect. Why serverless was good here? Because it fits our traffic characteristic. It's like batch processing. It's nothing that requires a low latency. And we can survive if something goes wrong. We can just retry over and over again. And we really pay what we use for what we use. If we schedule everything, process everything, there is nothing to do for a couple of hours. So it's a big cost savings. And auto-scaling just took the problem out of our head. We still rely on this 1,000 concurrent Lambda, and it works well. So we don't need to plan any scaling. We just increase the usage. The same goes with Dynamo, S3, and all the serverless components we use. So we don't think about it. It's like one problem less, at least till a certain point. But what was not so good, or maybe a bit surprising, maybe not surprising, but you heard about cold starts probably already. It happened that we had a Java there on most of components, it was really because the company policy and the fact that the many libraries were written in Java. And for a Spring Boot, it takes around 30 seconds to start. If you have API gateway in front, it will probably time out on the cold start. So it's unusable for that use case. Even AWS SDK in Java takes some time to load. One of Hackathon's guys decided to write a very simple library for just putting things into queues and scanning Dynamo using HTTP endpoints instead of loading all the things. However, as you've seen, our Lambda were not exposed, and there was no low latency requirements here. I would say it was very pragmatic and good enough in our case. It was pragmatic in that sense that we didn't have to rewrite everything. We can wait 30 seconds, not so painful, especially when you have warm lambdas that doesn't bother anymore. And yeah, given the benefits we have from not caring about scaling and keeping servers up, I think it adds up. So it is bad for now. If you plan to do something low latency, you probably try Go, Node.js, but still the cold start exists. At the beginning, there was also cold start involved due to network interface. If it was inside the VPC, it was extra probably 20 seconds to boot it up. But right now, it's removed. AWS created a pool of interfaces, and it starts to work better. And the long-running task, this pumping scenario, at the beginning it was fine, like we had not a lot of reservation, just pumping in a matter of 1 minute. But at a certain point we started to reach those 15 minutes. And what you can do at such point, you can either start another Lambda or just get rid of Lambda. We took the first approach, but it's hacky. You need to read the context of Lambda, check how much time left, do I have a time to process it again or not? And yeah, you feel bad when you write that code and pass the remaining stuff to the next Lambda. If I had to do it from scratch, I would either start the container in the serverless fashion, as Tomek mentioned on the previous talk, using Fargate, or maybe took a look at step functions where you can define the pipeline and passing parameters retries.
Why not just add trigger to database and create each Lambda for...
You mean streams, DynamoDB streams. We thought about it, especially in the context of TTL, like set a TTL to check reservations at some point. But for example, TTL has very wide guarantees for even TTL says that it expires. We can set it for our deadline, even to send a notification to the traveler. But if you go to the documentation, you will see that there is a window of 48 hours. It will be triggered, so it's not kind of reliable. And we didn't want to risk with having crazy timings. And that's one thing. The other thing, you probably mentioned that you put something to Dynamo, so that's the notification to schedule it, right? But what if you want to do it twice a day, 3 times a day? There is no guarantee that the record will be updated after all the processing. So we decided to not go this path right now, but maybe we will revise it. But yeah, we thought about TTL for notifications, but this guarantee is very fragile. And to be honest, the whole pipeline could be a pipeline instead of central database, but that makes analysis a bit harder. There are business requirements that tells about calculating potential and checking records. Don't want to go into details, but they want to go to the potential customer and say, hey, we have your reservation from the past half a year. If you enable this, you will get as much saving as we calculated based on the data. But yeah, I agree it could be more efficient if we constant stream. And the biggest bummer, maybe surprising thing was that the environment is maybe not mature in serverless thinking. You just take the first library out of the shelf for the metrics. It was micrometer. And you have things like a sliding window, which takes 1 minute to aggregate histogram, you push it, and your lambda lives 5 seconds. And you need to do metrics synchronously at some point. So there are traps in some libraries that you have to keep in mind, that they are designed for long-running systems most of the times. And it might be surprising that something is not working, and you check it, and it's assuming that something will live longer than a couple of seconds. The other things like debugging, we have X-ray, but to be honest, never use it apart from playing with it. It was not very useful for me. You cannot SSH into running system. You need to rely on the logs, on the metrics, which is good from one point, but if you don't know what's going on, it might be hard. Okay. And yeah, regarding CloudWatch logs, if you're using interface, you probably seen that. It's also very unpredictable. And to sum it up, I like it. It was a big mind shift. Like for a couple of years, I was doing stateful things on servers. But if you stop thinking about servers and living application and start thinking about events and how to process event, modify them, and generate another event, it simplifies a lot of things. Like this design starts to be very simple, and thanks to that you can scale them very easily because it's simple input, simple output, simple compute power needed. Just put more of them. No need to think about updates, security patches, and kind of stuff. And that's one less problem. And for the prototyping, it's perfect. You're already in cloud. You have a small piece of code. No need for boilerplate. And what's more, you just put more lambdas, and you are ready for production most of the times. And yeah, but I love the simplicity. You can even go to somebody and explain serverless in half an hour and try the same with Kubernetes. Good luck. And I think we have a lot of problems. I wouldn't recommend using serverless for low latency application, maybe HTTP interfaces, especially if you have front-facing stuff. But I think that kind of problems will be resolved by the platform providers in the next couple of years as they are working on it. And maybe this will be the next baseline for our systems. And if you want to practice it, I invite you to check native.chmura.pl and subscribe there to the particular topics. We will notify you when the workshop is taking place. So I think, thank you.